In part 4 of our lesson on polar equations and graphs, we will determine the symmetries of a given polar equation. In this example, we will determine the symmetries of r equals 4 cosine of 2 theta. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. There are 3 types of symmetry for us to test. We'll start with polar axis symmetry test. And we know the polar axis is the horizontal axis, which in rectangular coordinates we think of as the x-axis. In the polar axis symmetry test, we will replace theta with negative theta in the polar equation. So the equation becomes r is equal to 4 times the cosine of 2 times negative theta, which is r equals 4 times the cosine of the quantity negative 2 theta. We have an identity that the cosine of negative a is equal to cosine a, and we can substitute that into the equation. So now it becomes r is equal to 4 cosine of 2 theta. And this equation exactly matches the original equation that we started with. So that means, therefore, it has polar axis symmetry. Next, we will test for symmetry to the line theta equals pi over 2, which we know is the vertical axis. In rectangular coordinates, we call that the y-axis. And the test is that we replace theta with pi minus theta. So then the polar equation becomes r is equal to 4 times the cosine of 2 times pi minus theta, which is r equals 4 times the cosine of the quantity 2 pi minus 2 theta. Now we can apply the difference identity for cosine, which we know is cosine of a minus b is equal to cosine a cosine b plus sine of a sine of b. And our equation becomes r equals 4 times the quantity cosine of 2 pi times cosine of 2 theta plus the sine of 2 pi times the sine of 2 theta. We can plug in function values. Cosine of 2 pi is equal to 1. Sine of 2 pi is equal to 0. So our equation becomes r equals 4 times the quantity cosine of 2 theta plus 0, which simplifies to be r is equal to 4 cosine of 2 theta. And once again, the equation that we simplified to is exactly equal to the original equation. So therefore, it has theta equals pi over 2 symmetry. The third symmetry test is for pole symmetry, and in rectangular coordinates, that is equivalent to the origin. In polar coordinates, to do the test, we will replace theta with pi plus theta. So the equation is r equals 4 times the cosine of 2 times pi plus theta, which is r equals 4 times the cosine of the quantity 2 pi plus 2 theta. We see that we will have to use the sum identity for cosine. Cosine of a plus b is equal to cosine a cosine b minus sine of a times the sine of b. Working that into our equation, we get that r is equal to 4 times the quantity cosine of 2 pi times the cosine of 2 theta minus sine of 2 pi times the sine of 2 theta. We can substitute in the function values. Cosine of 2 pi is equal to 1. Sine of 2 pi is equal to 0. Our equation becomes r is equal to 4 times the quantity cosine of 2 theta minus 0, which becomes r is equal to 4 cosine of 2 theta. This equation is exactly equal to the original equation, so therefore it has pole symmetry. So it turns out that r equals 4 cosine of 2 theta had all three symmetries. It has polar axis symmetry, it has theta equals pi over 2 symmetry, and it has pole symmetry. The fact that it has all three symmetries will make the graphing of this polar equation go much more quickly.